Good morning, everybody. My name is John Arthington. I'm a professor in beef cattle management and nutrition and center director here at the Range Cattle Research and Education Center. I want to thank you for attending, those of you here in person, and then also those that are participating on the webinar. What we're trying to do throughout the year is all of the faculty programs are taking an opportunity to deliver a webinar that covers some of the highlights of their program, but also an overview related to the owner report that is published every month in the Florida Cattlemen and Livestock Journal. And so what I wanted to present to you this morning is a presentation entitled Selenium Nutrition of Grazing Cattle in Florida. A lot of what I'm going to talk to you about is related really to the entire Southeast, but I want to present to you the importance of selenium as a micronutrient to grazing beef cattle, but also explain to you some of the problems that we have found with getting selenium into our cattle and some solutions that we're working on. So I want to also point out Juliana Hanchez, which is a PhD student in our program that is working in this area right now and has done a lot of the work that I'm going to present. As an overview, I want to tell you a little bit about why selenium is important and talk to you about the requirements, deficiency, and toxicity. Tell you a little bit about the uniqueness of selenium in Florida and in most of the Southeast, and then some of the supplementation systems. So here's a slide that Juliana put together, but I just briefly want to point out that the reason that selenium is important is that it acts as a cofactor for antioxidant enzymes. And in fact, it serves as the most important cofactor for the strongest antioxidant called glutathione peroxidase. And what this enzyme does is it reduces compounds that can be damaging to cells, like hydrogen peroxide or oxygen-free radicals. And these compounds are produced normally in body of cattle and in our bodies for just general cell respiration, but more predominantly, when your immune system is activated, they produce these compounds to help kill bacteria or other foreign invaders. But if they're not neutralized, they can harm the cells that they come in contact with, both locally and generally. And so glutathione peroxidase helps to reduce these down to lesser reactive species. One of the things I'd like to point out is that we have two trace elements that are really important in Florida and in many places around the country and the world that are found to be limiting in warm season perennial forages, and that's copper and selenium. And they work together to orchestrate a really strong reducing or antioxidant pathway where superoxide dismutase, which is copper dependent, reduces oxygen-free radicals to hydrogen peroxide, and then glutathione peroxidase will reduce that further to water. And so they work together in conjunction. What's also interesting is that in Florida, the forages that our cattle eat are really low in both of these elements, and both of them are strongly antagonized by sulfur. And so we run into sulfur in many different areas, and I'm not going to focus a lot on that, but three of the most predominant ways that cattle consume sulfur are from sulfur, ammonium sulfate used fertilizers as a nitrogen source, can add sulfur to the diet. Also through high sulfur feedstuffs like distillers grains, molasses, feather meal, and then also from atmospheric deposition. Some of you remember acid rain, and that can add sulfur to the landscape and increase forage sulfur. So the requirements are really not that high, only 0.1 part per million in the total diet. And this requirement does not consider selenium source. We know that organic selenium is more available than inorganic. And even within the inorganic sources like selenite and selenate, there are differences in availability. It also doesn't consider the influence of sulfur. And so if your cattle are consuming a high sulfur diet, they have different selenium requirements. And there's really very little evidence that a cattle would require greater amounts of selenium than this 0.1 part per million requirement. What's also interesting about selenium and makes it unique from all the other essential trace elements that really are of relevant concern in beef cattle nutrition is that plants do not require selenium, but they do require all of the other elements that we often talk about. And so plants take up selenium in what we call luxury accumulation. So if selenium is present in the soil, the plants will take it up and then the cattle will consume it. But the plant itself does not require selenium. So the FDA regulates selenium, and it's the only element, really the essential trace elements that they regulate. And the reason for that is there's some areas of the country that have high selenium soils. They call them seleniferous soils. And as I explained before, the plants will luxury accumulate this selenium, and the animals that eat it could have selenium toxicity considerations. This is particularly a problem in the Intermountain region, parts of North Dakota and South Dakota, and where some of the wildlife like antelope, deer, elk have selenium toxicity issues. And so they've regulated this to 0.3 milligrams per kilogram of the finished diet. Now I told you that the requirement's 0.1, so this is 3 times the requirement that you can put into a finished diet. But what we're most interested here in Florida with grazing cattle is how much can we supplement a day? And FDA regulates that to 3 milligrams of supplemental selenium a day. And you've heard me talk about this a lot. If I'm on producers' ranches and I'm looking at their free choice mineral supplement, I try to figure out how much selenium are those cattle getting if they consume the targeted amount. And generally in Florida, those supplements are formulated to meet that targeted amount. So if you go around the country, north of here, the High Plains region, a 4 ounce a day mineral product is generally very common. That's when you'll see those products containing about 25 part per million selenium. You come further south, generally the better formulated products, you'll see greater amounts of selenium in them. For example, here we feed a product that's 60 part per million selenium, but we tag it for a targeted intake of 1.75 ounces a day. That's how we can put the 60 part per million selenium in it. That results in 30 milligrams of supplemental selenium a day, provided the cows are eating that targeted amount. So the reason behind all this is this issue of selenium toxicity, which is probably far more overblown than what it actually is, particularly in areas that have low soil selenium. Lee McDowell did several studies looking at the tolerance of beef cows to high levels of selenium and found them to be quite tolerant. Toxicity generally will occur from careless formulation. So because it's toxic, the formulators will make a premix. It's generally 1 to 3% selenium. And then the feed company will blend that premix into the finished feed product. And then that helps to dilute it out and protect it from mistakes. But mistakes do occur. In my time here in Florida, I have only seen cattle die from one instance of selenium toxicity. And that was a ranch in DeSoto County where it was a good producer and he was concerned about the mineral nutrition of his cattle. And a salesman came and said, you need to feed a high selenium supplement. And it was a good supplement, and he purchased it and fed it. And then when the winter time came, the person selling winter supplements, energy and protein supplements, said, we fortify our supplements with high levels of selenium, and that's good for your cattle. And so he bought that. And then in the spring, another salesman came and said, we offer a selenium injection because selenium is important to your cattle. And he bought that. And 1, 2, 3, it was the injection that ended up killing the cattle. Now, it wasn't the fault of the injection, right? It was the fault of the 3 of them on top of each other. And so there's an example of toxicity that can occur from careless supplementation of too much selenium. I talked to you about some of these plants that can accumulate selenium. We don't really have these in Florida that cause any concerns, but other parts of the country do. And so toxicity can be a problem. Both what we call acute toxicity, which is generally the result of consuming a poorly formulated diet, or chronic toxicity, which can occur from consuming these plants that accumulate selenium over time. So how does selenium impact our cattle in terms of cow-calf production systems? For cows, the problem is retained placentas. Whenever cattle, we see this in the dairy industry a lot. We don't see it as much in the beef industry because we don't monitor retained placentas as much as a dairy producers would. But whenever we have low selenium, we have an increased incidence of retained placentas. And what that does in the beef cattle industry is it slows uterine involution, and then it increases that anestrus period. So you have more days before that cow becomes pregnant because of this retained placenta issue. The other one is white muscle disease. And this is a clinical manifestation of selenium deficiency in calves. And what happens is, because you have so much cellular degradation because of the reduction of this antioxidant enzyme, you start to have these white striations in the muscle tissue and in the heart tissue. And when they post or do an autopsy on the calves, they see this white condition. They call it white muscle disease. What I believe that we see a lot more of is this weak calf syndrome. And you hear this word used in Florida a lot. Calves are born and they're just not vigorous. They don't get up and suckle well. And the veterinarians here use this word called weak calf syndrome. What I think that a lot of that can be related to is low selenium status in those calves, but not at the level that is creating the acute white muscle disease. And then impaired immunity is the other area that could manifest itself into poor response to vaccination. So here's an example of some heart tissue, muscle tissue, where you can see those white striations from a calf that died of white muscle disease, and the relation of that to this weak calf syndrome, I think, is a cause and effect that would be interesting to look at. Here's some data. This is actually dairy data, but it helps to re-emphasize the importance in immunity. And what Bill did here, he's a professor at Ohio State, he went around and he sampled the blood selenium status of dairy herds, and then just simply correlated that to the somatic cell count of the bulk milk tank. And what he could find is that there was a real strong negative correlation between somatic cell counts and selenium status. As herd selenium status went up, average bulk somatic cell counts went down, showing another relationship between selenium and immunity. So I want to show you some data here that kind of brings it to the southeast and the problem that we have. In 1996, there was a survey done looking at trace mineral status of grazing beef cows in the southeast. And what they found is that over a third, 35%, were found to be selenium deficient. These were in cows that were receiving supplemental selenium. In Florida, we did a survey of 14 ranches and looked at trace mineral concentrations of those ranches, and 5 of 11 were found to be selenium deficient. Now, 3 of those ranches came from a single owner, and that's why I didn't put them in here, because his cows were found to be very high in selenium. And when we went back and looked at the supplement that they were consuming, it was formulated inaccurately. It was supposed to have 60 part per million selenium, but instead was formulated at 90 part per million selenium. A very well managed cow herd, and because it was well managed, it was getting mineral thoroughly and regularly, and those cows were consuming a lot of selenium. So if you get it in the cows, it works. Here's a survey of soil selenium status across the United States, and the dark colors are where you have high selenium soils. All right, and the very light areas are where you have low selenium soils. And if you look here, the only place that we have adequate or high selenium in Florida is in the Okeechobee agricultural region. Now, at one time, there were a lot of cattle in that region, but not today. So the rest of the state has very low to almost devoid soil selenium, which results in forages that are very low in selenium. I like these data here because it shows you the impact of consuming these forages. Now, this is a selenium content of hamburger that was taken from cull cow hamburger plants at different parts of the country. If you look at the selenium status in the hamburger from North Dakota, which is known to be a high soil selenium state, it's quite high, isn't it? But compare that to Virginia and Missouri, which is known to be low soil selenium content, and that hamburger is very low in selenium. So there is a cause and effect relationship here, and it extends out over a period of time. Here's some data looking at some tissue, meats, sirloin, and liver collected from finished steers. And those steers were brought from a low selenium region or a high selenium region of the United States. And then they were fed together consuming a selenium adequate diet until slaughter weight. And look, they still have differences in selenium status even after they've been in the feedlot for a period of time. So that brings up this whole idea of getting selenium in these calves prior to weaning and having a positive outcome after weaning, we believe is a premise that is important to pursue. Now, cows can have varying levels of trace mineral status, and they will give everything they have to the calf at birth. So even though our cows might be in marginal selenium status, calves are born adequate in selenium. And so here's some data with calves at 150 days of age. They have very adequate selenium concentrations. But even though they and their mothers are provided a selenium fortified supplement, the calf selenium status drops rapidly up to weaning. And at the time of weaning, at 250 days of age, they're selenium inadequate. These are our heifers in that picture there that were raised right here at the research center, consuming a well-fortified selenium supplement, but their selenium status is inadequate at the time of weaning. So this presents the problem. Why are they inadequate? Well, one of the reasons is they don't eat a lot of that free choice supplement. So here's an example of 18 weeks evaluating 8 herds of beef calves, cow-calf herds here at the center, where we're able to divide out what the cow eats and what the calf eats. During the summertime, our cows crave salt, so they eat plenty of selenium, but the calves don't. They don't eat enough. And here's the variation in free choice mineral intake over that 18-week period, and they're only consuming 1.3 milligrams of selenium a day. But they're consuming a supplement that contains the federal maximum amount of selenium, so they just don't get enough. And that is perpetuated by other problems. We already know that the forage is very low in selenium, but milk is a very poor source of selenium. So now, the sources that the calf has is the supplement, which we see is not enough, milk, which is very poor source, and the forage, which we know is inadequate. And that's why these calves have inadequate selenium. They don't eat enough of that supplement. And so the focus on selenium status of these gestating cows to ensure that the calves have adequate selenium status is a problem, because we can address the cow, but we can't address the calf with the same principles that we have available to us. So what is the impact of supplemental derived dietary sulfur on the selenium status of calves? I had several slides to talk to you about this, but I wanted to focus more on the supplementation of the calf, so I'm only going to show you one. But previous research has shown that supplemental sulfur will interfere with calf selenium status and cow selenium status. We know that that's the case. We've ran a variety of studies here at the center to see if our supplemental feeds or high sulfur forages also interfere with selenium and copper, and it does. But we've not been able to find a way to work around it. In the case of selenium, that we're federally mandated for how much we can put into the calves, and the calves just don't eat enough of that salt-based product to overcome the antagonism or the problem. And then also, the sources of selenium that we have available to us, they're inadequate to overcome the sulfur antagonism as well. So we're unable to do it through amount because we're federally regulated, and we're unable to do it through source because all the sources act the same when faced with this high sulfur antagonism. So we've looked at a couple different things. Juliana Hanches, on her master's work, she looked at a topic called selenium biofortification. And it's interesting because certain regions of the world that also have very low selenium in the soil, that results in the production of cereal grains that are low in selenium. And they have identified this to be a human health concern. And so in some areas, and the one that's the most predominantly cited is in Finland, they created a federal law to add selenium to the NPK fertilizer for their cereal grains. And that's resulted in an increase in the selenium concentration of cereal grains by somewhere around 15 times more selenium. And since those grains are then fed to the poultry and to the swine and to the cattle, that the individuals are consuming, it's resulted in 2 to 6 times greater level of selenium going into the individuals consuming those. So there is some idea that biofortification can work. Jeannie Hall is a professor at Oregon State University, and she really started working in this area several years ago, and we got some of the early ideas from her. We looked at what had been done here in Florida, and Lee McDowell had looked at fertilizing hay pastures with sodium selenate, and this was Bermuda grass hay, and he could clearly see a quick increase in selenium content. This is some work from Jeannie Hall, and she was able to show a dose-dependent response. They add more selenium to the hay fields, and this happened to be alfalfa. You would see greater concentrations of selenium in that hay, and then the calves that ate it would result in greater concentrations. So we worked with João Vendermini, and we fertilized using sodium selenate that we dissolved in water and sprayed on Tipton 85 hay fields to produce high selenium hay compared to low selenium hay. And when we look at feeding calves this higher selenium hay forage versus consuming inorganic sodium selenite at the same amount, we see increased concentrations in the liver of these calves when they consume the high selenium hay. Now, what's interesting about that is when we pair feed them, this is an important slide, and I talk about this a lot, but probably don't do a good job explaining it. The way we did this is we took pens of calves and we gave them hay for a 2-hour period of time, high selenium hay, and we let them eat all they wanted. Then we measured exactly what they ate, and we took what's called a paired pen, and we fed that paired pen the same amount of selenium, but from an inorganic source in feed called sodium selenite. That's what we normally put in our salt-based supplements. And if those paired pens consumed less than 3 milligrams of selenium a day, there was a big difference in the availability. So you see over here where those calves consumed less than 3 milligrams a day, if they consume it from the high selenium hay, they have a much greater selenium status. But if they consume over 3 milligrams a day, which remember, that's the federal maximum limit, there's no difference in the sources of selenium. So we would like to follow up on these data a little bit more and look at possibly using selenium fertilization in weaning pastures, where if people are getting close to weaning or just after weaning, could fortify the selenium content of those forages for those calves to optimize the selenium status and the outcome at the time of weaning. Now, the final slides that I want to show you are what we're looking at right now. And this is related to what we call limit creep. Okay, so many of you know what the word creep feeding is, and that's where you supplement calves in an excluded area from the cow prior to weaning. And the idea behind that is that you'll get greater gains in those calves. But those of you that might not know much about creep feeding, there's a downside to that, and that is that the gain that you get is the most inefficient gain of any sector of the beef production system, the creep feeding gain. And that is, if you look at the amount of gain that you get, divided into the pounds of feed that it required to get that added gain, it's very inefficient. And so people generally don't like this idea of creep feeding just because of the cost and the inefficiency. But this is different. This idea of limit creep feeding is feeding calves less than a pound a day. And our target amount has been 1/4 to 1/2 pound a day at a period of time prior to weaning. And what it does is it exposes the calves to formulated feeds other than forage, and it also gives you an opportunity to deliver functional nutrients like trace elements to the calves prior to weaning, hopefully to overcome this selenium problem. It also gives the calves, something that we've learned, an interaction between humans and feed, so that when they're weaned and they go into a grow yard, they already can associate people with feedstuffs, which I don't know much about, but we certainly see a difference in those calves that have had that experience. So I had other data I wanted to show you here, but in the paying attention to brevity, I just want to point out that this has been troublesome. The problem with it is that when we formulate these pre-weaning supplements, the calves don't like to eat them. They won't eat them. Many times we would go through a whole supplementation period, they would eat very little. But if you provided the same supplement without the trace minerals, they ate it just fine. There's nothing wrong with the supplement, because if we take the amount that they don't eat and we give it to the cull cows or throw it over the fence into the bull pastures, they eat it perfectly fine. But calves have a very, very strong sensitivity to taste. This is what we believe. And they eat it, when they take this feed stuff into their mouth, they almost act like that it has an offensive flavor or offensive taste. Now, Dr. Vendermeany told me I can't say that because we don't have any way to evaluate what the calves are tasting. But what I can tell you is they don't like to eat it, and other calves will. And so what we hypothesized is that this high concentration of soluble minerals was creating a metallic taste in their mouth. And this metallic taste was not as sensitive to adult cows. One thing we know is that there's probably over 100 times more taste buds in the mouth of a calf than there is in a mature cow. They decrease rapidly over time. And there's probably some evolutionary significance to this, but certainly we can see it in terms of their ability to be finicky about what they eat. So we tried everything. We tried to formulate diets with high levels of dehydrated alfalfa meal, which is very palatable. We tried different candy flavorings and molasses, dried molasses, peat pulp, all kinds of things. And we could get by a little bit, but we never really solved the problem until we started to formulate the rations with sources of trace minerals that had low solubility. That solved the problem. So we started to use these trace minerals that are called hydroxychlorides. At neutral pH, they're virtually insoluble. So in the mouth of the calf, they can't taste them. They don't dissolve. Probably doesn't create the metallic response, and they eat them just fine. Now that solved the problem. And I just want to show you here, if you look at the hydroxychlorides versus the sulfate sources, there's a big difference in the amount that they eat. And over the period of time, if it's either no mineral or the hydroxychloride formulated, they'll eat about the same amount. And that results in improved trace mineral status at the time of weaning. So we were able to solve the problem through this approach. You can limit creep these calves prior to weaning, a selenium fortified diet, and they will eat it, and it will result in selenium adequacy at the time of weaning. So through that approach, we feel like we've solved that problem, but nobody's doing it today. Why is that? Because there's other problems associated with this whole approach. I want to talk to you about those. Well, I guess I don't have that slide, so I'm going to tell you about them. And the problem is that it requires the owner to go out and hand feed those calves every day. So it's very labor intensive. And even though all of our creep feeding studies, including the work that Dr. Vendermeany, Dr. Morel had done about 2 years ago, Dr. Vendermeany and I summarized all of them, and we're showing 19 pounds of added body weight gain. Added body weight gain, 19 pounds at weaning, which more than pays for the supplement. But nobody does it because 19 pounds is not that impressive when you've got to go out and feed your calves every day, right? And then there's also not really the buyer doesn't really see an added advantage of buying a selenium adequate calf today. And so there's not a whole lot of value that the buyer sees. And so it makes the grower, the cow-calf producer, less willing to adopt this management procedure, particularly when it certainly adds to his or her labor requirements. So we started to think about this and try to come up with other ideas. One of the ideas is using a limiter. So there's a lot of meal form products out, feeds that are provided free choice with limiters added to them. That's one approach. The other is these low moisture molasses blocks, and that's what we're working on right now. So in collaboration with Jim Drouillard, he's a professor at Kansas State University, and he has an ability to make these small blocks for research purposes. And so that's what we did. It eliminates the need for daily hand feeding. They're resistant to rain and weathering, which is important in Florida in the summertime. We were hopeful that they would be self-limiting to less than a pound a day. That was our goal. And we can formulate them to deliver these functional nutrients. So we ran first studies last year. We ran 2 studies. One, looking at just preferential intake. If we added minerals, would the calves still eat them? We found that they would. They ate them quite well. Then we ran the next study where we provided these two calves either with or without mineral for 84 days prior to weaning, just like we did in the studies that I showed you before. We looked at calf performance, intake, and mineral status. So here's the calves out on pasture, and gives you kind of an idea of what it looked like with them consuming those block supplements. Over those 84 days, there was a difference. The calves that were consuming the mineral-fortified block, they ate a little bit less than the ones that contained no mineral. It was significant, but the difference in average daily gain was not significant. They still gained the same amount of body weight. The blocks were successful in limiting those calves to consuming less than a pound a day. I was very happy with that. Jim thought that they would consume not more than a half a pound a day. So he was a little bit dissatisfied that they consumed that much. But I think overall, it worked very well. What he explained to me is that as air temperature and humidity goes up, generally free choice intake of these low moisture blocks also goes up. So that might explain it for the South Florida situation. But over this 84-day period, it really was not that big of a difference. Now, what we were happy to see is that it also increased trace mineral status of those calves in terms of selenium, copper, zinc, and manganese. And particularly for selenium, if you look at the no mineral calves, even though they ate about 0.8 of a pound of that block a day, they were selenium inadequate at the time of weaning, selenium inadequate. But those that consumed the selenium fortified block had adequate amounts of selenium. So very happy with the results. That was just year one of a 2-year study. We'll be running the second year study with those blocks this summer. So I have a few summary slides. I tried to convince you that selenium was important to grazing cow-calf herds, but that it not only is chronically deficient in Florida, it can also be toxic if it's supplemented inadequately. It's probably the most impactful trace mineral impacting grazing cow herds in Florida and subsequent feeder calf health, but it is regulated by the FDA, and so we got to be concerned about that when we think about supplementation. It impacts cows and calves through its role as an antioxidant. And so in terms of cow fertility or cow reproduction, it impacts them in terms of incidence of retained placentas, which results in lengthened postpartum anestrus, and then overall response to vaccination and immunity in calves. Calf vigor and estrus interval in response to vaccination. And in Florida, weaned calves, and particularly in the Southeast, all over the Southeast, are commonly selenium deficient. And the reason for that is that our forages are low in selenium because the soil is low in selenium. The calves don't eat enough of the free choice mineral that we provide to them, which is federally mandated with the amount of selenium we can put in it, and milk is a poor source of selenium. We've shown here with some of our work, and Jeannie Hall has in Oregon State, that we can use this idea of biofortification, adding selenium to our fertilizer to increase forage selenium concentrations, but there's some management complications there, and that solutions or products are really not readily available to producers to use. Limit creek feeding has been shown to be effective. We published results that have solved some of the problems that we ran into early on, but it requires a lot of labor to accomplish that. Special consideration to formulation is important, and it's difficult to really realize that return on investment until we can convince the buyer that selenium adequate calves are more profitable to them. And then we're working right now looking at self-limiting options like this low Molasses Creek block to deliver selenium to our calves. And it seems to be quite effective, at least in our first year of research. So with that, I'll thank you for your attention and address any questions that you might have. Thank you. Sleepy? No? Maria? No, I'll repeat it.
You mentioned that But are there any studies evaluating the environmental consequences of adding selenium to non-target organisms? If it's not taking the plant from the soil, easily move to the water body and then.
Yeah. So the question is, has there been any studies looking at maybe the environmental consequences, ecological consequences of adding selenium to the environment? And I am not aware of any in the U.S. However, Oregon is the only state that has pursued a state approval to add it to fertilizers. And they've been able to get that approval in Oregon. The fertilizer companies have been very resistant to adopt it because the plant doesn't have a selenium need, and it adds further liability to the fertilizer company in terms of potential toxicity to the calf. So at least one state that's known to have strong environmental laws, like Oregon, has allowed it. But I don't know of any studies. It is federally mandated in Finland to add it to fertilizers. They must add it to fertilizers of cereal crops, but certainly not here in the U.S. Right now, South Africa is considering a very similar mandate for corn, for maize crops in South Africa because of the suffering that they have with low selenium status. Are there any questions from the video? Okay. Any other questions from folks here?
I do. It's probably a stupid question, but once you fertilize with the selenium, how soon can you let them graze?
Yeah. So the question is, once you fertilize, how soon can you let them graze? And I don't know the answer to that. Dr. Vendermini and I, we talked about that quite a bit because Jeannie's done some work with what's called speciation. What form of selenium is in the plant, right? So when she collects her harvest, you can take the hay and analyze it for selenium, but you don't know what's organic, been taken up into selenium-containing amino acids like methionine or cysteine, or what's inorganic, found maybe just residue on the plant. So we were a little concerned with that, so we waited until we had a couple rainfalls on it to wash it off of the surface of the plant. So she's never had any incidents of toxicity, and she's fed some really high levels. We've only have our one experience here, so I don't know. But I think that that's an important consideration. The whole idea with toxicity is really related to this chronic toxicity that is found in the Intermountain region and in the Dakotas, where animals consume high levels of selenium for months upon months upon months. And the only issues with acute toxicity are these issues where they consume a diet that was formulated incorrectly. They just get a bolus amount. Some of you here in Florida might recall the polo ponies that died recently from, or a year and a half ago, from a diet that was formulated incorrectly for selenium. But in these areas of pasture application, or even in supplemental selenium to cattle on pasture, there's very little evidence. I think that we've got a lot of room to work. Okay. Well, thank you everybody for your attention, and anybody that is participating on Polycom or on the webinar, you're always welcome to send me an email or give me a call if you have a question I can address. Thanks.